I hope makes everyone excited about the future missions that we're going to have and the exploration we're going to do and the science we're going to develop to make sure we can send Americans, mankind throughout the universe. And so, but we do want to lean into this exciting news that we have today. And to give us more, I'm going to turn it over to Nikki Fox, who is the Associate Administrator for our science mission. Nikki?
Thank you so much. Thank you. Yes, it really is an exciting day today. NASA, what we do is we study the seemingly impossible. That's what we do every day at NASA Science. And NASA Science is undisputably the global authority in the search for life beyond our home planet. And so today we are going to talk to you about this amazing, exciting discovery. And I also want to make sure that we put context around it. And you see like how it fits into our search for life in the universe. Our galaxy is 100 billion light years across. And within 10 light years of Earth, there are at least 400 known planets. And that means there is a possibility, some would even say a probability, of life beyond Earth, including maybe even complex intelligent life. And today we are really showing you how we are kind of one step closer to answering humanity's one of their most profound questions, and that is, are we truly alone in the universe? So if I could have the first image, please, that would be great. So last July, as Secretary Duffy eloquently described, NASA's Perseverance rover found a leopard-spotted rock at Mars. And scientists immediately knew. It was interesting, we hadn't seen anything like that before on Mars. And we talked about it last summer. The moment we found it, we put out the images for everybody to see and everybody to share in the joy of NASA science. And, you know, today, we're really here celebrating that incredible hard work of the science team as they literally tried to prove it wasn't interesting. Maybe it's just something else. Maybe it's not, you know, the key result that we've been waiting for. And so they've done the analysis on these leopard spots, and we think they are potentially made by some sort of ancient life. This finding by our incredible Perseverance rover is the closest we've actually come to discovering ancient life on Mars. And if you can't tell, we're really excited about that. But, you know, I want to put it into context. It's a signature. It's a sort of leftover sign. It's not life itself. And it certainly could have been from ancient life, and that would have been something that was there billions of years ago, nothing that's current there. And, you know, it could certainly, as we say, be made by ancient life. And what that means is we look at everything we know about life on Earth. And this is the kind of signature that we would see that was made by something biological. In this case, it's kind of the equivalent of seeing like leftover fossils, you know, leftovers from a meal, and maybe that meal's been excreted by a microbe, and that's what we're seeing in this sample. And, you know, again, as Secretary Duffy said, we don't know for sure that's what it is, and we won't stop after this first analysis. This certainly is not the final answer. But we have this first result, and we're sharing it with you, the world, and we are asking you to look and give you our analyses also. And that's what we do in NASA Science. This is, you know, how we find our information. It's part of that long journey. We ask a question, we design a mission that can actually go and address that question. We develop the technology, we build the hardware, we launch it into space. It takes the data, it brings back the information that we need here, we analyze it, and we come up with answers to those really, really tough questions. We've actually been studying Mars with, even as early as 60 years ago when we sent our first missions there to take pictures of Mars and tell us really that's quite an interesting place and we really do want to send humans there. And so we've been doing this so we can understand the planet so we are ready to send our humans there. We certainly, as we look forward, we plan to send more missions to Mars in support of the Artemis program, which we're really proud of. And it will open the door for humans to study and better understand the red planet, and perhaps even one day bring back Martian samples home for us to actually study here on Earth. And I want to underscore the point that NASA science discoveries do not just happen at random. They are the rewarding results from meticulous, long-term strategic planning. We send these missions to really address these incredible questions. And each new discovery helps us just, kind of drive what research is coming next. What missions do we want to design next so we can kind of take that full bench of tools with us to solve the problems of how best to support, to explore our solar system. First with robotic missions and then with humans. And before I pass it on to my colleagues who are going to tell you all about the details of this incredible finding, I just want to talk a little bit more about how NASA searches for life. And there's so much happening that I am incredibly excited about. We have Europa Clipper that is on its way to explore an icy moon of Jupiter to investigate whether the subsurface ocean underneath that icy crust has the potential to support life. After that, we'll launch Dragonfly, which has been deemed the most exciting science space mission of your lifetime. And it's a drone, it's the size of an SUV, and it's going to be humanity's first airborne science mission to another world. Dragonfly will explore the amazing world of Saturn's moon Titan, which is the only place in our solar system where that have lakes of liquid on the surface. And with Dragonfly, it's going to let us understand the prebiotic chemistry that predominated Earth here before the origin of life. And the other thing we're looking for all over the universe is potentially habitable worlds. 30 years ago, we first discovered an exoplanet around another star system, and today we know of thousands of them. This has changed the very way that we look at our night sky. We know that there is, on average, a planet for every star in the sky. And as I've been saying, each new mission is specifically designed based on all of the knowledge that we've gained so far. And in this case, the knowledge is allowing us to lean forward to study a concept mission that is supported in the president's budget called Habitable Worlds Observatory. And that will allow us to search for habitable worlds and for signs of life around 100 of our nearest stars. Super, super exciting. From its vantage point in deep space, it will observe a variety of critical targets for us to go and explore, for us to sort of put our fleet of telescopes staring at those, including our amazing James Webb Space Telescope, and of course our upcoming flagship mission that we launched in 2027, the Nancy Grace Roman Space Telescope. Super excited, yay Roman. The Habitable Worlds Observatory insights could help keep astronauts and human infrastructure safe in space, and it will be the most powerful telescope NASA has ever launched, maintaining Americans' leadership in space, which is so important.